Consider a computer system with 10 physical page frames. The system is provided with an access sequence A1, A2, etc. up to A20, then again A1, A2, etc. up to A20, where each AI is a distinct virtual page number. The difference in the number of page faults between the last in first out page replacement policy and the optimal page replacement policy is dash. So this is a question coming from operating systems topic regarding page replacement policy. So here they are asking for this particular access sequence, given that we have only 10 physical page frames available for the process, what will be the difference between the number of page faults generated by the last in first out page replacement policy and the optimal page replacement policy. So let's take a look here. First of all, we have 10 physical page frames. The access sequence is 1, 2 up to 20. So we'll keep on adding 1, 2, 3, 4, etc. up to 10, and once we reach 10, all the 10 page frames will be used up. Now all these 10 were initial access, so all of these will create one page fault since this was not already available, right? And it's the first access, so 1 to 10 will anyway create page faults. After that, when it comes to page 11, we don't have space in frame, so we need to swap out 1. And they are saying we are using last in first out strategy, meaning 10 came in last, so we will be removing 10 first and adding 11. So this creates another page fault. After 11, 12 we need to add. Again we will be removing 11 only because that came in last. So 11 will be removed, 12 added. Similarly 13, 14, 15, 16, 17, 18, 19 up to 20 we will keep on adding like this. So finally we will have pages 1 to 9 available and 20 also available. After that, what happens is we will be restarting again from A1. So we will be accessing A1 again. Now if you see 1 we already have. So 2 we have, 3 we have, 4 up to 9 we have, right? After that we will be trying to access 10. Now 10 we don't have, we only have 1 to 9 and page 20 available. So 20 will be removed and 10 will be added here, that will cause a page fault. Similarly again 10 will remove, 11 will be added, 11 will be removed, 12 will be added, etc. up to 20 will be added, each of which will generate one page fault each. So if you take a look, in the first run 1 to 20 all will create a page fault because it was the first reference. After that 1 to 9 will not create a page fault, but 10 to 20 all will create a page fault. So the total page faults for this algorithm is 20 plus 11, 20 meaning 1 to 20 in the first iteration and 11 in the second iteration, that is for pages numbered 10 to 20. 1 to 9 were already there in memory. So total 31 page faults will be generated using this. Now let's take a look at the optimal page replacement algorithm. For optimal, what happens is 1 to 10 will keep on adding in the page frames available, 10 page frames. After that we are trying to access 11. Now what optimal will do is when we have to remove one page and add a new page, we will be removing the page that will be referenced the last in future references. So we have to remove 1 to 10 and add 11. So when we have to do that, we will be looking at the future references. So in the future we will need to access 1, 2, 3, 4, 5, 6, etc. up to 10 and also more. So among these 10 will be the referenced last in the future. 1 will be referenced first in the future. So since 10 will be referenced last in the future, we will be removing 10 and adding 11. Similarly, we will be removing 11 and adding 12, 13, 14, 15, 16 up to 19. We will be removing and adding 20. So this will work just like the last in first out page replacement policy we did here, creating 20 page faults now. Now we will have the sequence again A1 to A20. So 1 to 9 is already there. Okay. Now we need to remove 10. Now we need to remove. Now we have 1 to 9 and 20 in the page frames. Okay. Now we need to remove 20 and add 10. But in last in first out page replacement policy, what we were doing was we were removing this 20 again and adding 10. But in optimal we won't be removing 20 because this was the second iteration, right? We want to add 10 now, but we can see that in the future 20 is being referenced. So 20 won't be removed. Instead it will remove any one of 1 to 9 only, since these won't be referenced anymore. So 20 we'll keep here, 1 will remove and add 10. Similarly any we can remove and add 11, 12, etc. up to 19. After that 20 we are referencing, but 20 was already there available in the page frames. For last in first out, the last 20 also created a page fault, but in optimal the last final 20 won't create a page fault, it will already be there in the frames. So the total page faults will be 20 plus 10. 20 is for 1 to 20 and the 10 is for pages 10 to 19. The last 20 will save one page fault by using the optimal algorithm compared to last in first out page replacement policy. So the difference is 31 minus 30, that's equal to 1.